Hi guys. Just get myself situated here. Oh. 1 second. All right. Now we begin. So, hi guys. My name is Paul Batchelor, and topic of my presentation title is Live Coding in Sporth, a stack-based language for audio synthesis. So, Sporth is a language that I've been developing for myself the past few years or so, and it's my main tool for composition and sound design. So, what exactly is this Sporth language? And I like to think of it as sort of a terse notation for describing modular synthesis patches. It's like a text-based modular synthesizer, containing over 130 unit generators or modules. These are things capable of generating and processing signals. And these can be interwoven and connected together to build sounds and patches, much like you would on a Eurorack system or a Pukla system or any other modular environment. So, for those of you familiar with other like musical languages, Sporth is sample accurate and audio rate everywhere, so there is no concept of a control rate like you have in something like Sprinklider or CSAM. And that makes some things easier, but with the price of having a little more computational overhead, but it's, in practice it's not too big a deal. So, Sporth is a stack-based language. And notable examples of stack-based languages include Forths, PostScript, and even the desk calculator application, Unix application, which exists on many computers called DC. These are all languages that revolve around this idea of a global stack. And these languages all exhibit sort of this postfix or reverse Polish notation system, whereby arguments precede function calls. So for arithmetic expressions like 1 plus 2, you'd have 1, 2 plus. For like C-like function calls, foo bar cat, you'd have bar cat foo. So stack-based languages have a very strong left to right control flow. And as it turns out, audio audio signals can be represented in a left-right fashion as well. So the two are generally very compatible, especially if you have a highly serial connection. And as it turns out, in many cases in practice, modular patches are more serial than parallel. So we begin our first demo, just seeing what Sporth looks like. So I'm going to jog to the back of the room here. Here I have my other device here, another laptop actually running this. So here we are. Okay, cool. All right, so here we are. The screen will be here. I'll try to talk loudly. You don't have to look at me. You just have to look at the screen above eventually. Let's just show you about the stack-based language. So what I'm going to draw for you in a second is just a simple sign, like a hello sign. We're going to actually build and expand upon this patch. And indeed, the kind of workflow for making music in Sporth is often this idea of making constants, turning them into modulated signals, and just expanding those constants. So, I'll be talking about that in just a second. Okay, plan B. I'm going to simulate some Sporth code here, and then just execute it on my laptop over there. Maybe if this is live, I can do my laptop over here. Is this live? Yeah, that's fine. There we go. Cool. Okay, so it's a little bit, it's a little offshoot, but you know we can adapt. So all this is a whiteboard. So okay, yeah, that's fine. Yeah, and that's fine too. All right. Thank you for bearing with me. So I'm gonna do some running around today. So we're gonna start with the simplest hello world patch simulated here, and we're going to kind of have an analog. We're gonna type over there. So this is, I give you the simplest hello world patch. So this is a sine wave. I hope you know what a 440 Hz sine wave is. I'll add more. So basically the way you read this, it's left to right. So the idea is you have numbers 440 and 0.5 on numbers. They get pushed onto this global stack. And sine is our unit generator. It actually pops those arguments off the stack, last in, first out, and uses those for amplitude and frequency respectively. Sine then goes around and computes a sample and pushes this onto the stack. This being the last item on the stack, it gets popped off and sent to your speaker. So it does this at audio rate, and it works in real time. I don't know why, but it just seems to work. So these are all stack operations underneath this all, and we can add more stack operations and expand on these signals. So I'm going to add some vibrato here, and you're going to hear this. It's just so. So this is a 6 Hertz sine, an amplitude of 10, and we're going to actually bias our constant signal here. The plus sign that I don't. The plus. I'm going to hurt. This is a new keyboard. Oh, I see it. This is. Is there a function? No. Let's do plus. Oh, actually, you know what? I got words. It's an alternative sign, so we got to add. So I'm going to run this. I'm just going to run this batch. I'm going to cut this. I don't need the screen. So, give me a second here. To recap, here's our sine. That works. It works. And this is our vibrato. There we go. Vibrato. All right. Okay. So, let's add some more modulation here. Here we have, put another sine here. This time I'm going to make it like a 2 Hertz sine. I'm going to make this a little more organized. 2 Hertz sine. And I'm going to put this through a biscale. And this takes a -1 to 1 signal and scales it to any arbitrary value, this time 0.5. Put one thing here, wrong keyboard. So 3, 1, sine, 0.5, by scale. And now we've got some modulation here. Make that faster, audio rate, and we can also add some modulation too on the frequency of this. So I'm reevaluating this in real time. So now you've got some modulation in that. Design. By expanding our frequency here with the random number generator. So like that. So there's no reason why we can't keep on expanding and expanding and expanding and expanding. And this gives us more and more interesting gestures and patches and stuff like that. So I want to skip stack operations for now just because of the time and technical operations. But basically, if you have, let me just go to the presentation mode here. Okay, cool. So basically, stack operations, dupe, and swaps. They are, if you know fourths, they can be used the same way to copy signals, and they can, for parallel processing and things like that. I talk about this in my paper, so be sure to read it and many more things. But what we're really talking about today is this live coding environment. And basically, I'd like to share a little bit about my workflow and how it's evolved over the few years. So, when I originally started writing Sporth, it was just not in the original scope of the language. I didn't even think I needed it. And I was hoping to use Sporth just to render audio files, and I thought I was going to be happy with that, and I wasn't. And as I started writing more Sporth code, and actually trying to make music with it, I had to make adjustments in the workflow. So this really evolved Sporth from being like a non-real-time offline rendering environment to this real-time live coding and audio synthesis environment. And looking back at my evolution here and building tools and workflows, I view these as sort of improvements to this overall creative feedback loop. And this is sort of a thing I kind of thought in retrospect. And a creative feedback loop is basically how I approach kind of composition, iterative design composition. So it's like this loop you go through a three-pronged process. Begins with compilation steps. So you write some code first, and then you compile it, and you convert your text into music and sound. And then there's a critical listening phase. And this is where you put down your programmer hat, you put on your musician hat, and you think about musically what's good about it, what's bad about it, and where does it need to go. At that point, you kind of put your programmer on, leaving your music hat on a little bit, and make some adjustments to your code accordingly. And then you recompile. Compile, listen, adjust, compile, listen, adjust, compile, listen, adjust. And this is just a never-ending loop until the piece is done. So when I first started out writing tools and workflows for myself, I did not have a great creative feedback loop. So right before Sporth, I was writing C code using a library called SoundPipe that I was working on. And it was a pretty horrendous workflow and very frustrating. First of all, the compilation step was a two-step process. I was rendering audio files at this time. I had to compile a program and then render the program to make the audio file. But even worse was the adjustment phase. And I just learned firsthand that C was not conducive to creativity. For every musical, and I'm a slow man, so it takes me a while to learn these things. I had to know for myself, but I really got to understand that for every musical idea I had in critical listening, required me to make several dozen adjustments of lines of C, and it just was error-prone and just not conducive to any productivity. So this big red dot needed to go away, and this is where Sporth was born. So SoundPipe Forth is what it's short for. And so this is built on top of my C library SoundPipe. And so now the adjustment phase is pretty healthy, and things are a little bit better. But as you can see here, the compilation steps and the listening steps have a problem because I'm still rendering stuff offline, and my compilation time is directly correlated to my critical listening time. So so for things like ambient pieces or slowly evolving modulations, this became a problem and a huge bottleneck. So I eventually thought, okay, let's see if Sporth can run in real time, and I built some real-time stuff for Sporth, and I tried it out. And I liked it more than I thought I would, as it turns out. So now things are looking pretty healthy, things are looking pretty balanced. I really like the idea of having a constant compile time for an arbitrary critical listening period. And this was really nice because suddenly I was able to do things like make adjustments while doing critical listening. So these steps start blending into each other, and they start becoming kind of one entity in a way. And they start blending, and it's almost perfect. I have a good time with this. But the loop's kind of broken, as you can see here. I've got some dotted lines in this chart. And this has to do with the fact that it's kind of a broken loop because I'm still starting and stopping. And this causes an interruption. So I sought to remove this and make it so I could start it and never have to stop it again until the piece was done. And this is where live coding comes in. So this is what happens to the creative feedback loop when you have live coding. The compilation step is perceptually instantaneous. It's seamless, and it's negligible in this model. So what you're left with is this bidirectional link between listening and adjustment. And like I said before, you're kind of doing both at the same time. Just like you do if you're playing an instrument in an orchestra or an ensemble, you're making adjustments. And as a result, I was really surprised with how much I like this as well. And not just, I didn't just enjoy it, I actually wrote better scored pieces and better compositions using this environment. So I learned firsthand that it's not just about having a well-scoped language for whatever your needs. You really need a good environment for writing that code. To end this, I'd like to show some pieces that kind of evolved that couldn't exist without having a live coding environment and this scope language. And I call these Sporth things. These are compositional etudes that I've written, compositional exercises, to help me learn about Sporth. Because it's one thing to build it, but it's one thing to write Sporth and actually understand what it means to write Sporth code. And so I typically write it in one sitting, in one go, and it's sort of this improvisational thing where this constant expansion of Signal. And these typically are self-contained. What you see is what you get. So there aren't any samples or external code. And I actually do have do we still have internet? Because I'd like people to see the code, and I want to play some Sporth things too. So if I could open a browser, if not, that's fine. I can adapt, but thank you for your patience, everyone. Oh, no worries. This is fun. All right, so this is my website. Oh, we're not connected to the internet. What's that? Networking. So let me this is my website. On my website, there's actually, okay. All right. We have green. Okay, here we go. Here's my website. Click on Vision, go to Sporth Links. And I actually have all these example patches. When I showed this one, it's called Play with Toys. It looks like this. And it sounds. So these are generative patches. They just kind of unfold, and that's another thing I like about this form is that you can kind of leave it running. It doesn't have a beginning, middle, or end. It just kind of hits that. So that's sort of a melodic one to give you contrast. And I've got more of a sound object here, like density. It's a little bit smaller. And, if you like L systems, you'll like this one. Is density. That's how much code there is. What do you see? And it sounds like this. And I'm evaluating these in real time, by the way, using my two more. I've got this one I call computer on the phone talking to each other. And it sounds like this. I'm going to leave this running. This one's called The Electric Dreams Sheep of Ambulance.
that was live coding in Sporth, or live coding and sports. Thank you. And you have 5 more minutes if you want to ask questions.
Yeah.
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 Yeah, I was asking about the readability. Sorry, I think it's
Yeah.
very interesting.
Yeah.
When you were talking about this, like fine Tony population thing,
Yeah.
I couldn't really follow what was doing what. Did you find that
It's true. It's not a problem for me, and not because it is hard to read, and going back, it is a problem. In general, I do one of 2 things for that. I'd be responsible, and I document it. So I'm going to go to another section here of my website to address this issue. I actually have a book on how to use Sporth, and so this is a good resource for people who want to learn it. So if you want to chatting robot past the talking mother, I actually have a literate documentation system for Sporth patches. In general, I find that the concept of just these signal routings, it's very difficult to actually represent these sorts of graphs in general. So, it's occasionally a problem. But since most of the time I'm writing and not maintaining this code, it's not too big of a deal in practice. But certainly. Anyone else? Cool. Yeah?
How do you say the state of your oscillators?
What?
How do you say the state of the oscillators?
Oh, so, yeah, so that there's sort of, each one of those words is sort of, what happens when you compile it is actually it gets compiled into a kind of syntax tree of sorts, and that has state in there. So there's memory that gets dynamically allocated. So you can do things for filters and oscillators and convolution and phase vocoding stuff and a whole bunch of other things, physical models. So that's how it is. Yeah.
Did you say you're using supercompiler, right? Or
no, this is I'm using SoundPipe under. So this is yeah. So I'm this is all so SoundPipe's a C DSP library. It's sort of a really portable library that can be, and I'm building on top of that. So it's all yeah. Another thing to know about that is Sporth is in addition to being a language, it has some embedded use too. So it's pretty easy. It's got a pretty sane API, or sane enough that you can actually use Sporth with existing workflows. So right now, I have working like a Chuck plugin, a Chuggin that you can run Sporth code in. I have a PD object for working Sporth in pure data. If any of you guys are iOS developers or anything, you've heard of AudioKit. Sporth is actually under the hood for many of that, as well as SoundPipe. And I've even written a native plugin for the Linux Multimedia Studio, which is a Linux digital audio workstation. So it's pretty capable API. It doesn't work too well on embedded systems, so for that I use SoundPipe, and SoundPipe actually works pretty well. I'm doing some work right now for a company that's actually using SoundPipe under the hood.
I don't know if you mentioned this already, but what's on your roadmap?
Yeah, so right now, I'm very interested. So right now, this is really interested in making this kind of a performance environment somehow. Right now, I don't think it is hard. I don't think it's suited for performance right now, just the way it's set up. So I've been thinking about ways of making Sporth, integrating it into a performance environment. Also, just kind of extending. I really fall in love with stack-based languages for creativity, and so just kind of bleeding out into other mediums like graphics and other things, and building other stack-based systems and integrate into Sporth is also what I'm thinking about. Yeah.
So you can write your own functions.
And so Sporth does not have the ability of making abstractions, but I built another language for more general purpose called Runt, which actually does enable you to build your own words on the fly. And so that is more of the concatenative spirit of stack-based languages. But Sporth is really, I leave it as just a notation. Yeah.
Do you feel like the syntax of the stack-based model forces you to put creative decisions or suggest creative decisions that other languages maybe wouldn't?
Oh, absolutely. I think, thinking really, forcing yourself to think in terms of a signal rather than a note was a hard adjustment for me. Just because, the idea of like a chord is just built into our notion of Western harmony. Undoing that, my years at music school, took a bit of work, but I think it was very satisfying because, suddenly in this world of computer music, I could explore really complex routings and gestures. So some things are really easy, and people doing Eurorack stuff will say the same thing. It's basically the same challenges. So, some things are really easy to do in a Eurorack thing. You can make some really amazing generative pieces that are absolutely beautiful and heartbreaking. You ask them to play like Mary Had a Little Lamb, they'll say, okay, give me a week. And it's definitely the same thing with Sporth. So they're definitely, you can't use Sporth for everything, but what it can do, I'm intrigued by. Yeah?
Are you actually shocking LMMS and things to be considered building a super collider?
Back at Karma, I was talking to some super collider people, and I'd love to, but I think, so the problem, I wasn't sure how memory allocation works, so I think for plugins, memory allocation is, So in order to make, so if you want Sporth to work, you need to place a function. It's kind of, with all audio development, it's like your code here. You need a place to allocate memory, you need a place to initialize memory, or initialize and allocate, and then you need a place to free memory. And I don't know, I think Sporth has, Super Collider has some sort of garbage collector or something. So I haven't looked into it, but I've been interested in it for a while, but yeah. Cool. Thank you.